Now, in this second case, we've got to remind ourselves what an integral actually is. So an integral is the sum of all infinitesimally small slices, dx slices of this y. Now, what that means is, if y is less than 0, we're summing up a large series of negative values. What this means is that our final answer is negative. Let me give you an example. If I tried to integrate, say I have this curve in red here, if I tried to integrate this region, if I just naively performed an integral, I end up with a negative answer. How this relates to finding the finite region is that we want these regions to be positive, so that all of these areas that build up our finite region add together to give us a total. So what we have to do is we have to be careful, and we have to swap the sign on regions that are below the axis so that our finite area gets built up to include all of those areas, instead of having this yellow value, for example, subtracting away from that total. So let's have a look at this question. A curve has equation y equals x minus 1, x plus 2, x plus 3. Find the area of the finite region. So remember, that's the area that's sort of pinched between the function line and the x-axis. The finite region bounded by the curve and the x-axis, exactly. So the first thing we're going to do is we're going to consider plotting this graph. Now, I know the roots are going to occur where this factor equals 0, for example, so where x minus 1 equals 0, x minus 1 equals 0. I know that a root is going to happen where x plus 2 equals 0, and I know a root is going to happen where x plus 3 equals 0. So my roots are going to be at x equals 1, we'll put that there, x equals minus 2, we're going to have to put that here, not really to scale here, and x is minus 3. Now, the actual shape of the graph I can figure out. I know that this is a positive cubic. I think the easiest way, though, is just to put it in the graph. So we see it's going to look like this. So we've got it dipping above the axis between minus 3 and minus 2, coming down and then swinging back up. So my function looks like this. So it goes wahey, wahey, and wahey. Not exactly to scale. Now we can do this integral. So to integrate, I don't really like integrating these factors. So what I'm going to do first is I'm going to expand my function out. So I've taken my first two brackets. I've done the old parrot-beak method. So I've done x times x is x squared. X times 2 is plus 2x. This is minus x minus 2. And then I've got this result here is being multiplied by my final factor, x plus 3. So I've put that into a grid. I've followed along and I've seen where everything multiplies. So x times x squared gives me x cubed. X times x gives me x squared. Minus 2 times x gives me minus 2x. And so on until we have this expanded function. Now, what we have to do is we have to integrate this expanded function to give us this finite region. So remember, the finite region are these spaces between the function and the x-axis. So there's going to be two regions that we have to integrate. We're going to have to integrate in terms of, so my area, or my finite region, will be the integral of the lower limit minus 3 to minus 2 of x cubed plus 4x squared plus x minus 6. And also, there'll be this other region between minus 2 and minus 1. Now remember, this is going to give us a negative value. So if we want to add this area to our total, I have to stick a minus out the front of this integral. That's dx, and that's x cubed plus 4x squared plus x minus 6 dx. Now with that negative there, this should all add up to make one large total. Let me just give myself some more room here. But all we're going to do for the rest of the problem is solve this integral. So area equals, I've got this first integral here, minus the second. That's minus 3 and minus 2, and that's minus 2 and minus 1. So let's do this. So I add 1 to that x power, that becomes 4. That's 1/4 x to the 4. Add 1 to that x power, that becomes 3. So that becomes 4/3 x cubed. Add 1 to that x power, that becomes x squared, and that's 1/2 x squared. Add 1 to that minus 6, so that's minus 6x. Minus 6 divided by 1 is minus 6. Now, obviously, this is the same integral that we're filling in over here. So I've got 1/4 x to the 4 plus 4/3 x cubed plus 1/2 x squared minus 6x. Now, all I have to do is execute these integrals. So what I recommend is doing them one at a time so that the computation doesn't become too complicated. So we're going to just look at this first one. I've got my two brackets minus here. In the first bracket, x takes on the value of minus 2. So that's 1/4 times minus 2 to the power of 4 plus 4/3 times minus 2 cubed plus 1/2 times minus 2 squared minus 6 times minus 2. And in the second bracket, x takes on the value of minus 3. So that's 1/4 times by minus 3 to the 4 plus 4/3 times minus 3 cubed plus 1/2 times minus 3 squared minus 6 times minus 3. So the easiest thing is to just go straight into a calculator with this. So I'm going to actually use a calculator that I have to hand here. So let's have a look. So home, calculator, we're going to go 1/4 times, you can skip ahead if you're watching the video, minus 2 to the power of 4 plus 4/3 times minus 2 all cubed plus 1/2 multiplies minus 2 squared, minus 2 squared, sorry I made a mistake with my calculator, which you can't see, which is very helpful, minus 2 squared, minus 6 times minus 2 times minus 2. Okay, so this first bracket here is going to be 22/3. Now, it's not especially exciting viewing, but I'm going to do the exact same thing here. I'm going to change that minus 2 in my calculator to a minus 3. So that minus 2 becomes minus 3, that minus 2 becomes minus 3, that minus 2 becomes a minus 3, and my first minus 2 becomes minus 3. And my second one here is 27/4. So I have my first integral evaluated. And now I'm saying I'm taking away, so this is all going to be in square brackets, I'm taking away the result of this second integral being evaluated. So this is between minus 1, so I've got 1/4 times minus 1 to the power of 4 plus 4/3 times, it's quite a long process, there's not really much you can do about it, plus 1/2 times minus 1 squared minus 6 times minus 1, and in this second bracket we take on the value minus 2, so that's 1/4 times minus 2 to the power of 4 plus 4/3 times by minus 2 cubed plus 1/2 times by minus 2 squared minus 6 times minus 2. So we just got to do that. So the lucky thing is I can just replace what I already have here with minus 1s and minus 2s. So I'm changing my minus 3s to minus 1s. It's all the same structure. So minus 3 becomes minus 1. And I get that this is 65/12 minus, and now I'm going to do one last long operation here. So that becomes a minus 2. My minus 1 becomes a minus 2. I'm typing furiously, you just can't see it. Minus 2, and that is a minus 2. So this is 22/3. So we're nearly there. So I have these two brackets. I have 22/3 minus 27/4 minus 65/12 minus 22/3. So we can do this on, I'll use the on-screen calculator for this. So 22/3 minus 27/4. Let's go home. 22/3 minus 27/4 is 7/12. So I have 7/12 minus 65/12 minus 22/3. 65/12 minus, I've forgotten, 22/3. 22/3 is minus 23/12. Oops. Minus 23/12. So my answer is going to be 7/12 plus 23/12, which is going to be 30/12, which will be 15/6, which will be divide that by 3, so you've got 5/2, which will be 2.5. So there you go, that's the area of this finite region, should be 2.5.